Hello everybody, this is a mini lesson video for 2.18, which is the directed line segments. So we're going to talk about what a directed line segment is, and then also talk about how we find those directed line segments by using the midpoint formula method or the section formula method. So first of all, what is a directed line segment? So before, we've talked about how to find the distance between 2 points by using the distance formula, okay? But sometimes they want us to find a length of a segment, but not the full thing or not exactly right in the middle, okay? So that's where these directed line segments come in. They are a segment between 2 points, A and B, with a specified direction either from A to B or B to A, and with a standard distance between the 2 points. So the directed line segment AB tells you that you start at A and go to B. But the directed line segment B to A tells you start at B and go to A. Just like we kind of did with our rays. Remember the first letter when we named our rays? That told us our starting point. And then the second letter told us the direction we were going. And this shows you here, the picture below, it shows you the difference from saying A to B versus B to A. Now, an example of these directed line segments is this guy here. It says, determine the point that partitions the directed line segment B to A into a 7:3 ratio. Okay, so B to A, notice B to A. So we are starting at point B and we are going towards A. And we want to break it up or partition it where it's 7 to 3. So 7 parts to 3 parts, and which would make a total of 10 full parts. So you can see that when we go from B to A, it is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 full units. So that's going to be easy for us to break this line segment up because it's 10 units long, and we want to have 10 full parts for our ratio. So when it says 7 to 3, we want to break it up to where when we put that point, we're going to have 7 on one side and 3 on the other. So let's see here. We got 1, 2, 3, 4, 5, 6, 7. So this point right there splits up that line segment to where we have 7 parts to 3 parts. And I'll kind of highlight where those parts are. Notice that the 3 is 1, 2, 3. Okay, and then the 7 is 1, 2, 3, 4, 5, 6, 7. So 7 parts to 3 parts. Okay, now that's pretty easy because the line is straight. It's horizontal, right? And we can count the full units and then just divide them up. If it were vertical, it would be the same easy thing. Just count the units and divide them up. But of course, you know they're going to make it a little bit harder. So I want to take a look at whenever the line segment is diagonal or slanted, okay? This guy is split up into a ratio where it has a ratio of 2 to 3, okay? You notice that? It has 2 to 3 because the pink versus red, okay? So the point in which they are breaking this line segment up is right here. And I'll highlight that different color. Right there. So the ratio is 2 to 3. The ratio is 2 to 3. So 2 parts to 3 parts. And the full amount of parts from A to B is 5. Now, be careful because I should have put this in here into our slides here, but this would be A to B, right? From A to B, it's split up with a ratio of 2 to 3. But if we were to say B to A, then the ratio would change. The ratio would be 3 to 2 because when you go B to A, it reads different. It's partitioned 3 and then 2. But it still has 5 total parts. It doesn't matter if you say AB or BA, it still has 5 total parts. I want to be clear on that. Okay, so when do you use each method? Now, the vertical and horizontal, that's easy, okay? We just split it up like a fraction and we count. when the total parts is a power of 2, you're going to use the midpoint formula, okay? And you're going to use it multiple times to find where you're going to partition your line segment. Now, what do I mean by the power of 2? That means 2 squared, 2 cubed, 2 to the 4th, 2 to the 5th. Oh, not 25. 2 to the 5th, okay? So that would be like a 2, a 4, an 8, 16, 32, 64. That does not mean that the parts are divisible by 2. It means that it is a power of 2. And these right here, these 6, are going to be the most common ones that you'll see, okay? Now, the other, if it's not a power of 2, you're going to use the section formula. So let me show you guys what I mean by total parts, though, okay? We got to be clear on what that means. So for the midpoint formula, let me delete that. So the midpoint formula would be these examples here. Notice that we have a 1 to 3 ratio, which what that means is that our total parts, we just add them up. So our total parts are 4. Okay, the 3 to 5, total parts being 8. The section formula, okay, well, back over here on this midpoint formula, the 4 and 8, those are both powers of 2, okay, because it's 2 squared, and this one is 2 cubed. The section formula, this is 1 plus 5 is 6. 6 is not a power of 2. Yes, 6 is even and it can be divided by 2, but it's not a power of 2, okay? 4 to 7, that has 11 total parts, and that is not a power of 2, okay? So notice the ones that are power of 2, we would use the midpoint formula. When they're not a power of 2, we're going to use the section formula. Now, don't worry. I know you don't know the section formula. We're going to talk about it, okay? But our first step when we're doing these problems is to figure out, okay, are the total parts a power of 2, okay? So the first ones we're going to talk about are the midpoint formula. And I want to just show you right now, our first step would say, okay, is this a power of 2? Is our ratio a power of 2? I haven't read the problem, but I have it highlighted here. I should probably read it first, right? A line segment contains endpoints at A, which is -5, 1, and then B, which is 3, 7. Determine the point that partitions the directed line segment A, B into a 1 to 3 ratio. There it is. Okay, let's think about this. 1 to 3 is going to mean that we have 4 total parts. Okay, 4 total parts. And 4 is a power of 2, so we're going to use the midpoint formula. Now you're going, what does that even mean using the midpoint formula? Okay, let me show you. So what would they're asking us to do? We have this line segment AB, okay? And we want to split it up to where we are partitioning it off 1 part to 3 parts, which is a total of 4. So total 4, we could split it in half, and then we would split it in each one of those halves in half. So now we have it divided into 4 parts, okay? Now we want the line segment A to B to be split with a ratio of 1 to 3. So this would be our 1, and then notice these 3 parts here would be our 3. Now, where does the midpoint formula come in? So if we use the midpoint formula on points A and point B, we would come up with our midpoint right there. And then if we use the midpoint formula again on A and M, we would come up with this point here. So that's what we're doing. We are applying the midpoint formula twice in order to find out where our partition point will be. Okay? So our first time to do our midpoint formula, we're going to use points A and point B, okay, to find their midpoint. So point A is located at -5, 1, and point B is located at 3, 7. Now, this would be our X, this would be our Y, this would be our X, this is our Y. So we've got X1, Y1, X2, Y2. So let's plug in for the midpoint formula. Remember, that's like finding the average of our X's and then finding the average of our Y's. Okay, so the midpoint formula says, and I have it written right over here for you guys, okay? We're going to add our x's, which is -5 plus 3, and then we're going to divide by 2. Now we're going to add our y's, which is a 1 and a 7, and then we're going to divide by 2. Remember, it's like the average. You add your x's, divide by how many there are. Add your y's, divide by how many there are. So the midpoint, or the coordinates for our midpoint are going to be at -5, 3, or -5 plus 3, which is a -2. We still have our over 2. Then we have 1 plus 7, which is 8. So we're going to divide it by 2. So our midpoint is located at -1, 4. Okay. That was our M. That is this guy right here. Okay. What we need to do now is find the second midpoint there, our partition point. Okay. Our partition point. And I'm going to call this P right here. So to find P, we need to find the midpoint of point A and point M. Okay, so let's write down where point A and point M are. A is located at -5, 1. And remember, that's our original A. That's what they gave us. Point M is what we just now saw for. Point M is located at -1, 4. And again, we're using the midpoint formula. So I add my x's, divide by 2. Add my y's, divide by 2. So x1, y1, x2, y2. So let's go ahead. Remember, we are finding our P, which is the midpoint of AM. So adding my x's, I've got -5 plus a -1. Don't forget those negatives. Then divided by 2. And then you add your y's. 1 plus 4 divided by 2. So it is going to be located at -5 plus 1, which is a -6. And then 1 plus 4, which is 5 divided by 2. So when we simplify down, it's going to be located at -3, 2.5. So when we can partition line segment AB at the point -3 and then 2.5 so that it has a 1:3 ratio. Okay, so now we're talking about the section formula. And these are when our total parts are not a power of 2. So I'll write that down. The total parts are not a power of 2. Okay, this formula looks kind of crazy. It looks kind of crazy because there's a lot going on here. But if you will label your ratio and label your 2 points with your x1, y1, x2, y2, it makes things go so much easier, okay? Take a look here that when we have our ratio, which is, in our formula, it's m to n, you're going to multiply your x and you're going to multiply your 2 x's by m and n, and then multiply your 2 y's by m and n. And then down here, where we divide them, it's to be m plus n. So let's just look at an example, okay? And remember, I am going to label. Y'all know I'm a big labeler, okay? So it says a line segment contains the points A, which is -3, 3, and then B, which is 12, -7. Determine the point that partitions the directed line segment AB into a 2:3 ratio. Now the 2:3 ratio, that means that it has 5 total parts, which is not a power of 2. So that's how I know I'm going to use the section formula. Okay, writing it out, my ratio is 2:3, okay? 2:3, which means that this is my M and this is my N. So I'm going to write those down. My M is equal to 2. My N is equal to 3. Okay. Now my 2 points. My first point, because I'm going A to B, my first point is -3, 3. So this is going to be my x1 and my y1. Okay, the next point is 12, -7. And this is going to be my x2 and my y2. So now I'm ready to ready to use my section formula. Okay, so it says m times x2. Okay, so first of all, my m, and all I'm doing is plugging into this formula here. So my m is a 2, and my x2 is a 12. And then I have plus my n, which is a 3, times my x1, which is a -3. All of that is over m plus n, so 2 plus 3. Okay, the next one, I have my m. Okay, now guys, over here, I'm figuring out my y value, okay, my y coordinate. So my m is 2 times my y2, which is a -7, plus, okay, I have my n, which is 3, times the y2 or y1, which is 3. And that is over 2.3. I mean 2 plus 3. Okay. Stick with me, guys, stick with me. So over here, I have 2 times 12, which is 24, plus 3 times -3, which is a -9. And then that is over 5. Then I have 2. Hold on one second. Okay, I wanted to make sure that I don't run out of room. So I'm just going to move things over a little bit, okay? So now I have, over here I have 2 times -7, which is a -14, plus 3 times 3, which is 9. And then that is over 5. So I have 24 plus -9, and that ends up being a 15 over 5. And then we have -14 plus 9, which is -5, and that is over 5. So simplifying it down, you have 15 divided by 5, which is 3. And then you have -5 divided by 5, which is -1. So we're going to partition the line segment AB. We're going to partition it off at the point 3, -1, and it will split our line segment into a 2 to 3 ratio. Okay, I know this is a lengthier video, but it's a lot of information, and I want to make sure that you guys have a good understanding of it. So here's just an example that we got to figure out. Are we going to use the midpoint formula, or are we going to use the section formula? Okay, so it says, find the point that lies at 2/5 the length of the directed line segment from the point 1, 1 to the point 11, 6. Now, the 2/5 right here, guys, that does not mean 2 to 5, okay? That does not mean 2 to 5. What that means is 2 over 5. So 2/5. 5 is your total parts, okay? 5 is your total parts. So since 5 is our total parts and 5 is not a power of 2, that means we're going to use the section formula. And in order to use the section formula, though, you have to know what your ratio is. Remember, because that's what we plug in for our M and our N. So our ratio would be 2 to 3. 2 to 3, because there's 5 total parts, and 2 of them are part of them, and then 3 would be the other part. Okay, so that means that 2 is my M, and N is my 3. And then we have our 2 parts, our 2 points. So we have x1, y1, x2, y2. It's time to plug in. Okay, so our M times x2. Our M is 2. Our x2 is 11. And then we have plus don't think I'm going to have enough room, so I'm going to have to write this bigger. Okay, now we have our n, which is 3, times our x1, which is 1. And that is all over 2 plus 3. Okay, moving to find our y coordinate. Okay, m is 2. And then we have our y2, which is 6, plus we have our n, which is 3, times our y1, which is 1. And that is all over 2 plus 3. Okay, simplifying down. You have 2 times 11, which is 22, plus 3 times 1, which is 3. And that is over 5. And then we have 2 times 6, which is 12, plus 3 times 1, which is 3, over 2 plus 3, which is 5. Okay, simplifying them one more time, or another time. We have 22 plus 3, which is 5, over 5. And then 12 plus 3 is 15, and that is over 5. Now we're going to simplify down one more time. 25 divided by 5 is 5, and then 15 divided by 5 is 3. So if we partition our line segment at the point 5, 3, then that will split our segment up into a ratio of 2 to 3. Now, I know this was long, but here's a great wrap-up slide and shows you or reminds you when we're going to use each one of the formulas, okay? So here are the formulas that you'll need for the directed line segment lesson. You can grab the screenshot of this or take a picture with your phone, but I will also post these notes in our geometry resource page. Okay, thanks a lot, guys. Remember, you can always rewind if you need to watch another example, okay? And always reach out to your teacher if you have any questions.